Hello dear students, how are you? Welcome back to the channel Section Mixture. I am your Ravi sir. Today let us solve the very important problem, that is simply supported beam. We will be solving in one stretch, that will be reactions RA, RB, shear force diagram as well as bending moment diagram and calculation. All the things. So please watch the video till end so that the concept will be very clear. Now, before that, the students should note down all the tricks regarding RB, RA and what are the shear force bending moment signs. Okay, let us start. Let us read the question. Simply supported beam, 8 meter span. Span is nothing but the length. Let us write the given data before drawing the beam. 8 meters span, that is nothing but the length. Next, 8 meter span is what? Carries point loads. What? Point loads of 10 kilonewton. Point load 10 kilonewton and 20 kilonewton. Again, one more load is there, 20 kilonewton. This is also point load. Point load 10 kilonewton and 20 kilonewton. Where they are at 3 meter. First it is 3 meter. Write down 3 meter here. 3 meter and another is at 5 meter. 5 meter. 10 kilonewton is at 3 meter. 20 kilonewton is at 5 meter. From where? From left support. From left support. You write down this. From left support. Next we will read the question. Full point is that in addition it also carries UDL, that is uniform distributed load. UDL. How much is the UDL? 10 kilonewton per meter. 10 kilonewton per meter. We know the load, but where it is? For 3 meters. How many meters it is there? 3 meters. From where? From the right support. How much it is? 3 meters from right support. Right support. These are the given datas. You need to write this so that there is no need of reading the question again and again in the examination. So we will draw the diagram according to the given data. Now, this is simply supported beam. Which beam it is? Simply supported beam. So there will be how much it is? 8 meter span. 8 meter span. 8 meter span. First one is over. 8 meter span, that is nothing but the length. Next, point load is there. How much? 10 kilonewton. 3 meters. From where? Left support. This is left support. This is right support. Left and right. From left, 3 meters. From left, 3 meters. 10 kilonewton. 10 kilonewton. Next, another load is there, 20 kilonewton of 5 meters. From where? Again from left support. 5 meters. Another load is acting. How much it is? 20 kilonewton. How much? 20 kilonewton. Both are over. 10 kilonewton as well as 20 kilonewton from the left support. Next, UDL is there. From where? How much it is? 10 kilonewton per meter. 3 meters is there. From where? Right support. From the right support. But we don't know this length. We don't know regarding this. So, there is 5 meters here. In 5, if 3 is gone, how much is the remaining? 2 meters is the remaining. How much is remaining? 2 meters. Correct? In 5, 3 is gone. 2 meters is remaining. 3 plus 2 is how much? 5. Again, we don't know regarding this. But we know 8 and 5. In 8, if 5 is gone, how much is remaining? 3 meters is remaining. This is very important. 3 meters. In 8, 5 is gone, 3 meters is remaining. Okay. What he has given UDL from right support. This is right support. So here there is UDL. How much it is? 10 kilonewton per meter. UDL is also over. Take the screenshot of this. This is very important. This is left support. This is right support. Now there is no need of the question. We have done with the given data and we are done with the question. Now we will name it. This is A. This is B. This is C. And this is D. A, B, C, D. First thing, we need to find RB. What we need to find? RB. That is reaction. RB. RB into distance. Take all the loads towards A. That is RB into 8. 8 is equal to what the trick says. RB. If point load is there, load into distance. If point load is there, load into distance. If UDL is there, load into distance, distance divided by 2. Now we have UDL. How much it is? 10 into 3. 3 divided by 2. 10 into 3. 3 divided by 2. We are taking the load towards the A. So there is remaining 5. We can rub this 5 so that there will be no confusion. This will be the complete diagram. Okay? Next, 10 into 3. 3 divided by 2 plus 5. Plus 5. Next, 20 into 5 plus 20 into 5. Next, one more load is there. 10 into 3. 10 into 3. If point load is there, only you need to multiply by to the distance. If UDL is there, multiply to the distance, then divide it by 2. We are taking towards A, so you need to add the distance, this distance. Fine. Next, we calculate this one. If we calculate this will be 30 in the bracket into, and this will be 6.5 plus, and this will be 100, and this will be 30. Next, if you add this one, it will be 130, this both, and this will be in the left hand side. We have RB into 8, RB into 8 as it is. This one will be 195. 195. If you add both, RB into 8 is equal to, if you add both, it will be 325. 325, and this is multiplication. If you take this side, it will be 325 by 8. Remember, RA and RB always they will be positive in reactions, and all the loads will be positive. If I divide it, I will get RB as 40.625. 40.625, that is kilonewton. I got RB now. What I got? RB. Write down here. RB is equal to 40.625 kilonewton. Next, I need to find RA. RA plus RB is equal to RA plus RB. What RA says here? If point load is there, only loads. If UDL is there, load into distance. Next, 10 into 3 plus only distance, 20 plus 10. You need to see the tricks. If you remember the tricks, everything is easy. Next, if I solve this, this will be 30 and this will be 30. That will be 60 over here. And this is RA. I know RB. What is RB here? 40.625 RA I will take 40.625 in the right hand side, that will be minus 40.625, and the answer will be 19.375 kilo Newton. I got RA as how much? 19.375 kilo Newton. You need to write RA and RB. Both I got here. Note on this. We will find shear force now. Now listen here. Shear force. A, C, D, B. Fine. Fast. Shear force at A. Shear force at C. Shear force at D. Shear force at B. Fine. A, C, D, B. A, C, D, B. What trick says? Positive. Negative, negative. Now it is positive. 19.375 kilonewton. That is positive. First one is over. Simple. Next, at C. At C, you need to take the distance. Whether you need to take the distance? Take the distance? No, because it is shear force. So, only point load is there. Point load, you need to add and subtract this because these are negative when you are finding the shear force. This is positive. Always need to remember. Tricks. Apply the tricks now because I am finding the shear force. 19 plus 375. Plus is there. Plus. And this is minus. Minus 10. Fine. The answer will be 9.375 kilo Newton. Fine. SF at C. Next, SF at D. 19.375. That is positive. Minus 10. Next, minus 20. At D, I can see 3 loads. 1, 2, 3 and D. Sorry, 20. Next, if I calculate this, I will get the answer as minus later we will calculate. Let us write at B. At B we will write 19.375 minus 10 minus 20 minus 10 into 3 plus 19.375 minus 10 minus 20 minus 10 into 3, and this will be minus 40.625 kilo Newton. SF at B. Calculate this one. This will be 19.375 and minus 30. This will be 625 and this will be 11.625. It is 11. No, it is 10. 10.625. Minus, it is correct. Minus kilonewton. Shear force at D. Yes, it is minus. Yes. over with this. Next we'll solve bending moment. Next, the bending moment signs are same and it is more easier than the shear force now. Now bending moment will solve it. Bending moment at A, bending moment at C, bending moment at D, bending moment at B. First and last, A and B always 0. 0 kilonewton meter, and this is also 0 kilonewton meter. Write in it, in simply supported beam, both at the support end, both with bending moment will be 0. Now we will calculate at C. See the tricks what it says. Positive, negative, negative. Bending moment at C, 19 plus 375 into what is the distance here? 3 over. Next, bending moment. Now place your hand on C because we are finding at C. Place your hand on C. I can see only this load 19.375 into 3, that is 3. Next, bending moment at D. How many loads I can see here? 19.375 into 5 because till D. Next, 10 into 2. 10 into 2. It's simple. Plus 19.375 into 5 minus 10 into 2. Over. The calculation is over. Next, the answer for this bending moment at C is equal to, this will be 58.125 kilonewton. This will be positive. Next, for this bending moment at D, for this the answer will be 76.85 kilonewton, and this is also positive. These are the answers. Let us draw the SFD and BMD, that is shear force bending moment diagram. The values this will be A, C, D and B. So A, C, D and B. And mark it. The values for 19.375 kilonewton, and this is also 9 point, this is 375 kilonewton. Shear force diagram, this is. Next, at D it is minus 10.625, and at B it is minus 40.625 kilonewton. Fine. Now point load is there. I will take steps here. Again, there is point load here, so I will take again step. Next, there is UDL. I will take incline, and I will close the loop. This is positive and this is negative. This is shear force diagram. And for bending moment, 0 and 0. At C it is 58 and at D it is 76. It is 58 here, 0.125 kilonewton and for D it is 76.875 kilonewton meter. Fine. Both are positive. Here there is point load, so I'll take inclined here. Fine. And till here it is inclined because point loads UDL here, so I am taking this parabolic or curve. Take the screenshot of this. Thank you for watching the video.